So let's build up a scenario here. So suppose you own 5 cars. So we'll see how we can understand about these 5 cars using vectors. Okay. So suppose when we spoke about cars, we have a type of the cars. Okay. So cars can be compact, minivan, SUV, roadster, or maybe a pickup truck. And when we talk about cars, the next thing which we comes to my mind, is what is the efficiency, basically mileage. So that's again a question when I pick up a car for myself. So how we will do that? So on the screen you can see I've just said that type, compact, minivan, SUV, roadster, pickup truck. Mileage. So mileage is like 1256, 237, 6780, 1000, 12,000. So now you remember we spoke about C function, whose utility is about combining the things. So you can see on the screen we are creating a mileage vector, and if you see they are numbers, so it's a numeric vector. And you see in one case I'm doing it on a console. In second, if you see in the bottom of the screen, I'm assigning it name. So why I'm assigning name? You remember from the previous session, we are giving a name to the mileage data so that I can reuse it when required. So let's do a bit hands-on. So here it is. So see, if you see, I have just created few minutes back. So if you see C 1256, 237, 6780. So if I press enter here, it will give me on the console, it will show me what I've just created as mileage for the pickup truck, for all the cars which we spoke about. But I cannot reuse that unless I assign a name to it. So you see this mileage. Okay. So this is what a mileage vector we created. So now when I want to see what is there in the mileage, I'll type mileage and press enter. So it will give me what is stored in the mileage vector. So now another one you remember was type. So see what we are doing. Type C, compact, minivan, SUV, roadster, pickup truck. And when I press enter, so do you think can anyone guess what will happen? Does it create a vector type for me? No. What happened? An error came. And what you start reading the errors. So what the error says, unexpected symbol type in compact truck and all. So do you understand what is the problem here? We are trying to define a character vector which is type. So in character vector, you remember what we have to do? We have to give the values in quotes from the previous class, which we learned. The previous session we learned about this character vectors. So always remember what is the differentiator between character and numeric vector is the difference of quotes, because we are giving input as a string, so we have to put that into quotes. So this is how R identify it's a character vector. So now you see when I did that, I type enter, you see again. So you can use arrow screens to come to your previous command in R. So if you see type, now I put given type and now I press enter, it will create a character vector. So when I type, hit enter, it gives me everything which I stored in the type vector. So what we learned in this small demonstration, that how to create a numeric vector again, plus in character vectors, if we forgot to put quotes, it will throw error, and we should be able to understand what is the issue. And if you would give quotes, we'll again be able to create a character vector. So next topic is how I select from a vector. So if something is there in the vector, I want to extract that. So how will I do that? So our goal is to specific elements of the vector. To select that, you remember in our first session, I spoke about square brackets. So now those will come into play. How square brackets come into play in R is a demonstration we'll see in few seconds. So to select elements of a vector, you can use square brackets. So if you see this, I've created a vector X combining 37, 23, 24, 54, 34, 12. Now if I want to see the third element of this vector. So I know that is 24. So if I put x square brackets 3, so it will give me 24. So let's see in the console. So let's assume, let's not go in there. So let's assume I have a mileage. Okay, I've already created mileage and I want to see the mileage for the third car. Okay, so you see 6780. So this is how I extract from the vectors. So now it's a time I'll introduce a tip for you guys. So the tip in vectors is, so the tip is that R is case sensitive. So when I say case sensitive, it means that R identifies something in the lower case as a different object and similar similarly defined, similar name in a caps uppercase as a different data object. So for example, in this case, if you see, I've created type with a small t, right, beginning in the lower case. So type type. So it identifies the type of the cars which we just defined. Now when I give same type a capital T, it throws me error, object type not found. So this means what? R identifies case sensitive. R is case sensitive. So R, if you give a smaller case variable or an object, it will not be replaced by a uppercase one. So that's how R operates. That's how R is built. Similar in case of mileage, if you see small m, we create a mileage, it identifies, but in the capital M, it says object not found. So tip here, R is case sensitive. So today in this session, let's review what we did. We spoke about, we basically spoke to pick up a case of cars, and we defined a type vector, which is a character vector, and we defined a mileage vector, which is a numeric vector. Plus we saw how we extract elements from a vector, and we introduced the first step, which is R is case sensitive. So now in future sessions, we'll see how this case sensitive thing works. And again, whenever you make any error in R and you are debugging that error, so this is the first thing you should check. Are you using the right case or not? So thank you so much. Let's start another topic on R objects. So we will learn today about matrices, basically matrices. So in R, we are moving from vector now to matrices. So matrices is what? You remember rows and columns, two-dimensional. Okay. So vector was single dimension. Now we'll have two dimension. We will have rows and columns on top of it. So just focus from a syntax perspective on the slide. I'm showing a syntax. So I'm defining a matrix capital M here. So I'm assigning, so what is the syntax here? We have to understand. So capital M is the name of the matrix which I'm assigning. Then matrix, matrix, is a keyword. It's a keyword. Basically, it's a syntax which R will identify when I input this matrix to understand I am coming up with the objective to define a matrix. Okay. So capital M is the name of the matrix. Matrix is a keyword. Then I'll putting the arguments. Okay. So now first one is 1:9. So what is this 1:9? This first element here is for the data which I want to arrange in a matrix. Okay. So over here, what I'm arranging 1:9. So it means I'm arranging a range of numbers from 1 to 9. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9. Next one is number of rows and number of columns. So over here, if I ask you a very simple question, I have 9 elements and I want to arrange them in a matrix kind of format. So I will require 3 rows, 3 columns. So that's why I'm giving 1:9, 3, 3. I'm sorry. So this is how we define a matrix. So if I want to select something from this matrix, okay, so how will I give? You remember again square brackets. We discussed in the first session about square brackets. Now in matrix also we have a square bracket. So I want to extract first row, second column. So my first row and maybe second column. So where it will intersect, it will give me that cell element out. it will give me that single element which is stored at first row, second column. So I have to give M matrix 1 square bracket 1 comma 2. So let's assume I want to remove elements from the matrix. So I will use negative subscripts for that. Negative subscripts. So M -1 -2. So I will use minus sign to negate things. Okay. So over here, what will happen? It will remove first row and second column. So whole first row will be gone and second column will be gone. Okay. So we'll see the demonstration later. So if I talk about matrix, it's a two-dimensional array. Okay. And what is an array? Array has n dimensions. So you can have n dimension. But in the scope of our series, we will be talking about two-dimensional. So we'll be working towards matrix, and I'll tell you about big data sets, big data objects later. But right now I'll talk about matrix and arrays. So for an array, I'm defining Z. Over here, again the syntax is array. Then I'm combining C 3, 4. So basically I'm combining 3 and 4 rows and columns into this. So right now let's not focus about arrays. We'll focus only on matrix, and we'll talk about this later, like maybe in few sessions. But right now the scope is two-dimensional array, that is a matrix. Okay. So we'll see some hands-on. Let's first see on a screen, and then we'll do it on a R console. So I want to create a simple 2x2 matrix. Let's call it M. So what will be the syntax? Again, name of the object, small m this time, matrix, the keyword. I'm putting data. Again, understand this data is a label. Okay, it's a keyword. If you give data 1 or something, it will not identify. It will identify only data. But I'll tell you a shortcut for this later when I'll demonstrate. So data combining 2, 3, 4, 5, 4 elements. Number of rows, I've given it for your understanding. If you don't give n row also, it will identify the number of rows. Number of columns 2. So M matrix data C 2, 3, 4, 5, n row 2, n col 2. So now when I define it, I want to see what is there in the matrix. It will give me, I'll type small m, press enter. It will give me the numbers which are defined. Now again, in matrix, you remember from a high school days how that is arranged in a zigzag way. So I want to arrange 2, 3, 4, 5. I'll not go this way. I'll first complete the first column, then go to the second column, and then complete it. So if you see on the screen, it's coming 2, 3, 4, 5. Okay. So now first demonstration I've given you with the help of data and n row n col. But if you give this way also, no n row n col, it will define the same matrix. Okay. So let's do it hands-on. So I want to clear this screen. So Control L for that. Okay. So again, just cleaning up things. So we define a matrix, small m, keyword matrix. I'll show you the first one first, which we define 1:9, 1, 3 rows, 3 columns. I want to see small m. So this is how it's arranged: 1, 2, 3, 4, 5, 6, 7, 8, 9. So now let's see the previous slide one, capital M. So okay, before this, I'll just show you. Remember, we spoke about extracting square brackets 1:2. So press enter. So first row, second element is number 4. So I'm extracting 4 out of it. So now you remember R is case sensitive. So now if I want to define a different matrix, I cannot do small m. If I do small m, what will happen? It will override on the previous data object. So whatever you will give latest command, that will stay in the R session. The previous one is overridden by the latest one. So that's how R operates. So let's assume I don't want to do that. Maybe I require it later. So matrix again. Sorry for that. Okay. So now data C 2, 3, 4, 5. I'll just close it, comma, n row equal to 2, n col equal to 2. I just complete this. I guess all the brackets are closed. Let me press enter. No, I think I missed one bracket somewhere. Okay. Oh yes. See what error I did? It was I missed to give a comma here, so that's why it gave me error. So you can see this, it says data length is not sub multiple or multiple of the number of rows. So you can see how we have to read the errors. So I missed that comma, I give that, now I press enter, it came out capital M 2345, right? So now if I want to define without, let's assume without n row and without n call, so how it will happen? It can be like this. I can give 2 2, okay, press enter, now same matrix. Okay, so now let's assume I don't want to give data, okay, and let's assume I define, rather than data, I create an X, and now it's going to be single dimension, so I'll create a vector X 2 3 4 5, okay, outside the matrix. So I create a vector X. Now in the matrix command, capital M, rather than giving data, I'll pass small x, which I've just created. Okay, and now I'll press M, again it's defined. So, and if I want to extract from matrix M, again the same thing, 1 comma 2, right? So how we will do that? Sorry for that. It gives me 4 again, right? 2 3 4 5, first column, second row. And we learned about one more thing, negating things. Okay, so let's assume I want to remove first row, second column in this matrix. So I'll give -1 and -2. Okay, so I'll do that, press enter, it gives me 3. So understand, see here, first row and second column, so it has negate 2 4, which is part of the first row, and second column 4 5. So 2 4 5 all go out and only 3 is left. Okay, so if I type small m, capital M, previous matrix still says. You know the reason behind this? Because I have not stored this somewhere else. So my original matrix stays similar, but if I negate and I don't store that, then it will just show me the original matrix also. Now, but if I want to negate and then create a new data object, what is the best way to do that? I will, when I'm negating, I'll assign it to a variable m1. Okay, and now if I press enter and if I see m1, it will have a single element 3. So coming back to the slide, so what we learned right now, how to create a matrix and how to negate out of it.